In this lecture, we show you how to calculate the water flow rate in the chilled water and condenser water lines. We will use the well-known rate of heat transfer formula to calculate the water flow rate. The formula is Q equals M times Cp times delta T, where Q is the heat transfer rate in BTUs per hour, M is the mass flow rate in pounds per hour, Cp is the specific heat of water, that is 1 BTU per pound per degree Fahrenheit, and delta T is the change in temperature in degrees Fahrenheit. In case of the chilled water line, we can convert the water flow rate from pounds per hour to US gallons per minute and rate of heat flow from BTU per hour to tons of refrigeration. We then get the formula TR equals GPM times delta T divided by 24, where TR is in tons of refrigeration, GPM is the rate of chilled water flow in US gallons per minute, and delta T is the temperature change due to the heat flow in degrees Fahrenheit. In case of the condenser water line, the formula is similar to that for chilled water line, except that the heat gained by the water is the sum of the air conditioning load and the rate of work done by the compressor. The condenser water flowing from out of the condenser in the chiller is typically pumped up to the cooling tower, where it gets cooled down to a temperature approaching the wet bulb temperature of the air passing through the tower. Typically, the water is cooled to within 7 degrees Fahrenheit of this wet bulb temperature. On this slide is shown a 200-ton chiller with chilled water inlet temperature of 54 degrees Fahrenheit and outlet temperature of 44 degrees Fahrenheit. Using formula 2, the chilled water flow rate is 480 US gallons per minute. For the same chiller as in the previous slide, the power input is 120 kilowatts. The condenser water exits the chiller at 100 degrees Fahrenheit, while it enters the chiller from the cooling tower at 90 degrees Fahrenheit. Using formula 3, the condenser water flow rate is 562 US gallons per minute. In the next lecture, we will familiarize ourselves with components used in the chilled and condenser water lines. Thanks for watching.